Here we go. Oh, Dan just ran off. Those are intros. So we're getting started. Hopefully everybody on the call got to refresh. I still don't know if Marty ever came back or if he burned the chicken. Hopefully he's good. And so now this is our full talk for the night, and that will be Brooke. And generally don't need an introduction, but Dan does such a good job, I'll turn it over.
We pulled the meetup, that's where I have crib notes. So I know Brooke has spoken for us many times, and he's I'd say a stalwart of the Bold Ruby community. So thank you for doing this talk. He's been talking about Ruby functional Ruby function composition. And he is the founder and architect of Alchemists, which is it still a collective? Do you still call it the Alchemist Collective?
Yeah.
Okay.
I would like to make it bigger, but it's just me at the moment. So.
But it's collective of one, and focuses on software engineering. And actually, one of my favorite things about Brooke is that I've often thought about software as kind of one of the rare places where you can really be a craftsman and still earn like a really professional salary and not get rheumatoid arthritis, like you do if you're an electrician or a tradesman. And Brooke really exemplifies that craftsmanship. I really think he does. So thanks for talking.
Oh, thanks, Dan. That's
Make him blush and then
yeah, like
take it off.
I don't know how to respond to that. Thanks.
I just called you a software plumber, essentially.
We'll upgrade you to cabinet maker, maybe.
Those are to tear you down.
All right, so take away share screen.
Okay, let's see here. All right. I didn't grant access. This is the first time actually sharing on this new rebuild, so this should work out good. Let's see here. Okay. All right. Okay. Cool. All right. And then this is muted, so I think we're okay, right?
Yeah, around the call, that sounds good, yeah?
Okay.
Yep. Sounds great.
Right.
All right. Well, thanks, everyone. So I wanted to spend some time talking about functional composition in Ruby tonight. And I guess before I kind of jump into this and kind of break this down, kind of curious, has anybody used like procs and lambdas and just functional aspects of Ruby? Have they composed anything? Is this kind of, are you familiar in this territory, or is this all new? Just kind of curious, get the pulse.
Mostly,
Okay.
Mostly.
We've used a proc or two.
Yeah.
Okay.
Yeah,
So,
procs.
Yeah.
okay, good. All right. Well, I'll walk you through this, and then, as we go, feel free to ask questions and stop. We can dive into this as deep as you want to. But I'm going to walk you through how this all works in Ruby and then build up to there to something a little bit more sophisticated, which is pipelines. So from a very overview, from a high-level overview, we're going to focus on the fundamentals of Ruby.
Did you start recording?
Yes, thank you for asking. Is recording.
Okay. So we're gonna stick with Ruby and focus on the fundamentals like procs and lambdas, like I was talking about, and then build up from there, especially using composition, which is native to Ruby as well. Then we're going to add a little bit of monads on top of this. You don't have to freak out. I'm just going to spend a little time on it, just to kind of show how this glue layer works. And then we're going to finally wrap this up with the transactionable gem. Now, this is a gem that I maintain, but it basically takes all these concepts together and creates a way for you to build fault-tolerant pipelines so that you can actually be able to have a series of steps go through, and you can actually recover from those steps and still produce a result at the end. So it gives you a really nice, sophisticated way to build more complex architectures. So what is functional composition? Well, from the Wikipedia definition, basically in mathematics, right, is being able to take an input into a function that does some processing, spits an output, and then that output becomes the input to the next function and down the line. Now you can compose those together, or you can just kind of use the functional steps there. So that's kind of the rough definition, but I'm going to walk you through what this looks like as we get deeper into this. So from a high level then, if we just look at some code here, what I'm talking about here is on line 3, we have a lambda, right? And we're just taking a number and we're going to add 3. 3 is the default by in this case, right? So 3 to 3 is going to be 6. And if we take a multiplier, we could take some number times 3 and produce a result. So nothing too sophisticated there. We're just messing with lambdas. Now, where function composition comes into play, though, is when we can use forward composition in this case. I'll talk about forward and backwards composition a little bit more as we get into it. But we can take an adder function and a multiplier function and then process those two together to produce a result. So what this looks like then, if we walk through this, is we have 5 for the input, starts on the right-hand side, right? We're going to read this from the right-hand side. Then we're going to go on the left-hand side, and we're going to take the adder. Now the adder is going to take 5, and it's going to add 3 to it. That result is then going to be composed into the multiplier here, and then that's going to take that result times 3. And then it's going to produce 24. So the mathematical calculation for this is 5 plus 3, that result, times 3 equals 24. So how's everyone feeling so far? Is that tracking? Does it feel okay? All right. So before I dive into this a little bit further, let's just talk about the history of where this came into play into Ruby, and then we're going to kind of go full steam into building this up. So this was actually added in Ruby 2.6. We've had this for a while. If my math is right, this is about 4 or 5 years. So it's actually fairly new to the language, roughly speaking. And the methods that were added in 2.6 was forward composition that I was showing you there in the first slide, and then backwards composition, because we can actually compose backwards as well. Those methods were added to these objects, PROCs and methods. And we're going to dive into both of those as well in a little bit too, to just kind of show you really unlock this power that we have natively to Ruby. So let's focus on those fundamentals. And I'm going to build up by starting with procs, lambdas, methods, and then finally classes, because we can teach classes to behave this way too, which is really nice. So we'll start with procs. So with a proc, you'll see that we're actually doing a multiplier here. Not too much different from the first slide, but the thing that's the kind of telltale sign, right, is proc. We call it a proc. We're building a proc. And this proc is going to multiply a number by 3. Now, the way that we can kind of inspect this and look at this, we can see that if we ask the proc for its class, we'll see it's a proc. That's good. If we inspect it, we'll see that we have a little bit more information about the instance of that proc. And then if we call it, right, if we take 3 times 3, that's going to be 9. And the interface here, I'm going to harp on this quite a bit, right, is call. In Ruby, anything that you want to do to make use your functions like procs and lambdas, the main interface, the object API that you're going to use is always the call method. So then if we want to pass in 10, the number that we multiply by, so 3 times 10 is equal to 30. So nothing too special there. We're just messing with procs and we're spitting out some results. Now, if we take this to the next level here, we actually mess with lambdas. The only thing that is different in this implementation is we're using the stabby syntax. This is lambda syntax. And if we look at it, we'll see, hey, it's still proc. But the telltale sign is actually, when we inspect it, is in fact a lambda, because a lambda is a special type of proc. In a nutshell, basically, lambdas care about parameters coming in, procs don't. And then also when you return from a proc or a proc will return from the entire scope, the lambda will return from itself. So that's really nice. But we're not going to get into the return aspects of procs and lambdas in this talk. Just focus on the parameters. The parameters are key. So the fact that the lambda cares about the number and the number by that it's going to be multiplied by, a proc won't even care. You could pass in nothing. You could pass in more variables. It doesn't care. So that's the difference. Now, if we do the calculation on this, we call it, right, we're still seeing the same math go through, right? It's just the lambda, it's doing the same functionality. We still get 9 and 30. So if we take this one step further and we start bringing in methods, so let's say that we have this method here where I have a module, and I'm just going to open up this module, create a new module here, and I'm going to assign it to the calculate constant. That's going to be my new module. And then inside this module, I'm going to create a class method. And I'm going to call it multiply. And you'll notice that the implementation for multiply is the same that we've seen in procs and lambda so far. We're just multiplying numbers again. But the syntax is slightly different. Now, the thing that I need to do in order to make this a proc, so I can actually call it, is I need to grab that method multiply off the calculate module, and I need to put it into a new a variable here called multiplier. This is going to be my new function multiplier. And the way that we do that is we use method. So in Ruby, when you say method is part of object, I think, I sort of forget at the moment, but it's available to all your objects in Ruby. And you can send it either a string or a symbol. In this case, I'm using multiply the symbol, but that has to match my multiply method I defined up top. Now that gives me a method, which is great. And if I inspect it, we'll see that that method is part of the calculate module. So nothing too special going on there. But that is important to know where it came from. If we call it, which gives us the same API as procs and lambdas, we're getting 9, and if we pass in 3 and 10, we get 30. Pretty cool. Now, the one nice thing is about methods is that we can convert them to procs. So this is where lambdas come into play again. If we look at the function when we convert it into a proc, we'll see that it's a proc, but it's a special type of proc. It's a lambda. And that's, again, when I was talking about the parameters that go into it, this is really critical, because if we took that method off of that module and it didn't care about the parameters coming in, it's no longer going to be behaving the same way that we defined it within the module, if that makes sense. So before I move on, let me, any questions? Is that kind of tracking? Anything I can demystify?
So you're saying, like, with a lambda, if you pass in 3 arguments when 2 are possible, it will throw an error?
Exactly, but with a proc, you won't care about the third one.
Right.
It'll happily take, whatever those 2 numbers together and multiply them, but it won't care about the rest. Or you could just pass in nothing. It would actually throw an error when you're trying to times something by nothing, so you'll get an error. But it's not because the parameters were wrong, it's because the calculations.
So you won't get an argument error.
Yeah.
So you get an argument error, but you get a no class times 3 error or something?
I think you get a null error of some sort, yeah.
Okay.
But yeah, you want the parameter checking because that's kind of your first line of defense. You don't want to end up with that null object error later down the line, because that's a lot harder to debug versus an argument error, like Spike was saying. So, all right, so that's how we can use that same API for methods, which is really cool. We're gonna leverage those a little bit later.
Actually, sorry, bro.
Yeah.
Can you go back to that previous slide real quick?
Yeah.
Is the...
See if I can.
Messed up his sweet animation.
Find where.
Oh, God.
Yeah, here we go.
Yeah, sorry. So the lambda that you get by pulling it off the calculate method, is that essentially this exactly same functionality as you define a lambda manually?
Yes. So when I grab the proc here, that's what you're talking about. When I put it into that function variable, yes, that's the same thing as the slide before where I had the lambda.
So could you create a lambda and attach it to a class or attach it to a module?
Yes, dynamically you could potentially define a method on your module using that lambda as the implementation. So you could wrap it that way. You could do a little bit of meta program to actually wrap it around in there. Yeah, that would work. Yeah. I'm looking at Spike because I know you're a age-old Rubyist too. Is there? I know there's multiple other ways you can do that too. So. Okay.
I assume you can, but I don't actually know what the syntax would be.
Yeah, I'd have to think about it, but the defining a method at the class level and then wrapping the lambda or the proc in there would work. But there's other ways you could do it too. Yeah, that's not the only way. Okay, all right, I'll continue on here. So now if we go ahead and take this further and we actually wrap this up with classes, right? If we want the class to behave just like our method proc and lambda, we do it the same way, except we're just going to define a normal class like we've done before, right? This is pretty much natural to all of us, right? We're going to have an initializer here, a constructor. We're going to inject our little by number here that we're going to multiply by. And then the call is the key, right? In order to make it play nice with all the others, we need to have that object API to be the same. The implementation is basically the same at that point. If we take the multiplier and we look at it, we can see that it's part of the multiplier class. It's an instance of that class, so that's good. If we inspect it, we can see that it's got the instance variables and state, so forth. And if we call it, same calculation before, nothing special. The only thing that's different here is that because of the way that I implemented this, I'm sort of bending things a little bit, because in order to make this a proper class, I need to inject something into the constructor. If I didn't have the constructor there, it's no longer a class. I could put a call on the class, but that's not really a class anymore. It's not really good OO programming anymore. You'd really want to make it a module. and then have like a class method at the module level like I did in the previous slide. But the reason I'm doing this is just to kind of show you what this would look like using a proper class, right? I'm just sort of bending things a little bit here to play within this multiplier space that I've been using for all these objects. So now that you understand kind of the fundamentals of how procs, lambdas, classes, and methods work, now we can start composing these together. And this is where it gets really kind of cool and a little bit of fun, because it means that we can move these around in different ways and recompose these in different ways. So now we have our little building blocks, right, in order to make more sophisticated architectures or objects. So like the Avengers, it takes a little bit of assembly to actually pull this off. Not too much, but just a little bit. So what I mean by that is, in order for classes, in order to play in the same space as procs methods and lambdas, is we need to be able to teach our classes how to be composable. So the API for that is we need to have forward composition working, we need to have backwards composition, and we need to have the call method, right? The public API, the object API. And in this case, I just fail it if it's not implemented on the class when we include this module later. Otherwise, we really want to force whoever is making their classes or their objects composable actually to have some errors here. So this is nice. Now, what's nice about this is this is part of the transactionable gem. We'll get to this a little bit later, but the transactionable gem provides this, it's all built in for you, but if you actually wanted to use this within your objects, you would have this module there too. So what does that look like? Well, if we take our new class here, we're just calling it divider. We're going to teach it how to divide some number. The key is bringing in that composable module that teaches it how to do forward and backwards composition, and now we're off to the races. We already have our implementation and call. The number is going to get divided by some number. But the forward and backwards composition is now part of this class as well due to the inheritance that we brought in from that module. So now we're ready to go. So if we put these all together here, one last slide here, I'm just going to show you bringing back that calculate module again. I'm going to have that multiply class method on there. So when we have those four objects together, now we can start looking at them together, right? We have our adder, our proc, we have our subtractor, who's a lambda, we have our divider, which is the class, and then we have our multiplier, which is the method. And the only caveat here is that we had to teach the class how to be composable. Otherwise, it doesn't play nice with the other three in this list. So if we put these guys all together now and start composing them, really interesting things start happening. So if we start with just some adding and some multiplying, we're not too far off from the original slide that kind of kicked off this entire presentation, right? We're going to take an input of 10, we're going to add it, and then we're going to multiply that result, and we're going to get 39. Now that's using forward composition on the top. So forward composition, and if we look at backwards composition, the only thing that changes, right, is that we got to switch around our functions. Otherwise, the calculation is going to be wrong. So pay attention to that because order does matter. I'm going to emphasize that a little bit later here soon. But the calculations are the same. So that's critical. And the math here is no different than before. So now, the one thing I don't like about this is in both these cases, they're a little hard to read. And you might be kind of scratching your head thinking like, oh, it's not the greatest. And you'd be right. On the first example here, we have to read from the right. Then we have to read left to right. So it's a little funky. If we look at the second example, right, basically, we're doing backwards composition, but at least it all reads the same flow, but we're starting from right to left. And that still kind of sucks because it feels backwards still. Out of all those, I still like the first one because even though I have to start on the right to get the input, at least I can still read left to right, and that feels still natural, but it's still not perfect. I'm going to show you how to fix that in a little bit here too. So if we kind of take this a little bit further now, and we have our adder, multiplier, subtractor, and divider, we pass in 10 and we do all those operations, we're going to get 12. And I'm just kind of showing a little bit more of an extreme example, but 10 plus 3 times 3, then divided by 3 gives us 12. So no magic here, but again, we're kind of reading left to right, except for we had to start on the right to get the input. And then on the bottom, we're just reading all the way from right to left. So just emphasizing the flow here. The flow is really critical to how composition works. And again, this is just native Ruby. We're not doing anything terribly special here, but the things I want to show you now is that we can start composing these together and building new functions. So far, I've just been passing in input, and then we've been calculating that input and spitting out new output. But now what I can do is I can say, you know what, I don't really want to keep typing out adder and multiplier everywhere. I want to compose those into a new function called add and multiply. Then I want to compose subtract and divide into a new function as well. Then I want to take both those and I want to compose those into a longer method that does add, multiply, subtract, and divide. And then I'm just going to pass it in. I'm going to call it with 10 and I'm going to get out 12. So calculation is still the same as before. It's just that we were able to compose those into other building blocks that are built upon smaller pieces, right, to compose bigger, more complex pieces, if that makes sense. So how's everyone feeling about that? No mystery? Okay.
That almost looks like macros on the top.
To
get back to old, ancient programming languages.
Okay.
The first couple of it's like, you could do that with a macro.
Like, yeah.
Like in C or something, right?
It's been years since it's been a long time since I've written C, so I don't even remember anymore. But yeah, basically being able to have, being able to give something a name like this, right? And have it as something you can compose into later. So anyway, there's the math again. Now, the thing where I was emphasizing before on operations matter, right? The order of operations in this case, oops, I went a little too fast. I thought I could go back on these, but oops. There we go. So you'll see that on forward composition here, right, we're getting 10s coming in, but we're getting 39 as the answer. But on the bottom one where we do it backwards, but we didn't change the order of the functions, the calculation's different. So it's 33 versus 39. So again, the order matters in which you put these, just trying to emphasize that. So that's kind of a bummer because it can be a little subtle in terms of like introducing bugs if you're not watching this carefully. The other thing that's really interesting about this too, and again, Ruby's doing great work here for us. It's really opening up new avenues for us to write interesting code. But if we have a situation where we're trying to bring in an input of 10, we're trying to add it, and then we hit a division by 0 in this case, it just halts the entire operation. So just like a series of Christmas lights in a series of, in a series, right? If one of those lights goes out, the whole thing just goes down, right? So this is fine, but it's not great. So we can do better. And the answer for this, for kind of a better way, is basically the transactionable gem, which basically takes these concepts, builds upon that, and gives us a pipeline flow that allows us to have failures and successes, but we can recover for them. They won't just blow up in our faces like we've been seeing just with native Ruby. So now what I'm going to do is I'm going to take this to another level. I'm going to build upon composition, which we've been talking about this entire time in Ruby. I'm going to add in a little bit of dry monads, and then I'm just going to build this up into something that I can build composable pipelines. So from a high level, the way this works is we'll have some input, right? And normally the happy path is everything processes fine, we get a success, no issues. But with pipelines, especially this is the kind of railway pattern. The railway pattern, I don't have a lot of time to go into, but it's a really good pattern to dig into if you want to on your own. It's basically the concept of railway tracks. You could kind of look at what I'm diagramming here as railway tracks too, where you've got a track and then it forks and then it can fork again and so forth and then come back. So the way this works is if you have an error, you could kind of go down the not so happy path, but you could potentially recover for it, like being able to take that operation, turn it into something that could still be a success. You won't just throw an exception and blow up, you could actually turn it into something that makes it a success. In the case where that doesn't work, you can still try one last time perhaps and turn that into success. And if that still fails, then hey, at the end, well, okay, you do have a failure that you come out with. But with monads and the railway pattern, it gives us a way to recover from those, which is really powerful. This is not too different from other languages where you kind of, in functional languages, where you have the concept in monads basically having a success or kind of a failure path. It's one or the other. This stems from another language that I really love, Elm, which is basically an immutable, statically typed language that compiles down to JavaScript at the end of the day. But it basically is pure functions. And everything that you're dealing with is monads. So it's really wonderful. So it's nice to be able to see from other languages like Elm, we can actually get this functionality in Ruby and still stay within the language that we love. Now, I'll take a quick moment here and kind of pull some inspiration from Kurzgesagt, which is basically the rough translation from German to English is in a nutshell. And if you've ever, if you like science and math and love these videos, this is a good place to hang out. So just a little plug to them. Great stuff. But I'm going to take some inspiration and do a little nutshell on monads. So with dry monads, all you really need to know is you either have a success or you have a failure. Or in Elm, you either have just something or you have nothing. But the concept is the same here, where these are basically union or composable types. Basically, you're either a success or you're a failure. You're not both and you're not nil. One or the other, that's it. That's how monads work. So that's just kind of a quick, in a nutshell, how monads work. There's a lot more to them, but this is really the nutshell that you need to know. So let's look at a quick script of this, like how to put this together in order to build a program that uses all this. So what I'm going to do is I'm going to walk you through a little inline Ruby script here. I can't fit this all on one slide. If I could, I would, but I'm just going to break it down into a couple slides and then we'll just kind of compose it together. Now, stop me if this isn't tracking and we can go back to this. It's really simple code. It's not too complex. But what I'm going to do is I'm going to use a bundler inline script here. I'm going to bring in my debugging gems. Got to have debugging support. And then I'm going to bring in the excellent HTTP library. It's basically the best library in the Ruby ecosystem for doing API calls and HTTP requests. And then I'm going to bring in dry monads, and then I'm going to bring in the transactionable gem. So that sets us up for the script. That sets up our dependencies, and now we're going to build our class. So in this class, we're just going to build a pinger class here. It's just going to ping an API. The key thing is we're going to bring in transactionable. That gives us the DSL that we're going to work with. We're going to inject our HTTP client, just another dependency here that we're going to use later to make the HTTP call. And then we're going to basically start using the pipe command that comes from transactionable. This gives us the beginning of a pipeline. And in this pipeline, we're going to have a series of operations where we can do a T, a check, some method, as, and so forth. Now, this is all part of the DSL that's provided by Transactionable. The only thing that's not part of the DSL is the methods. Because remember, when I was showing you in the earlier slides, I'm pulling a method by the symbol, because that's native Ruby, and I'm going to get a method there so I can put it into the pipeline, because it adheres to the call API. All these steps in here have to adhere to call in order for this to work. So it flows really nicely. So let's take a closer look at this. So as we go down, let's explain how that method works. When I was saying that method get, right, in the pipeline step on the previous slide, this is where I'm pulling it from. I'm pulling the private method get and putting it into the pipeline. Now what this method does is it takes the monad, it's the result that's coming in, and then I'm going to do a function map to unwrap it. So don't worry about this too much. This is monadic code here, but just know that on a success, this block only fires on a success. If it's a failure, this code doesn't get called at all. So again, don't sweat the bullets on that. Just know that this monad's coming in, and then I'm going to say the HTTP client, hey, I want you to time out after 1 second in case you're trying to ping the server and it's not coming back. Just time out quickly, and then do a get request, HTTP get request on the URL that's coming in from the pipeline that we saw on the previous screen. Now, if that's a success, that's going to wrap that back up into a success, that HTTP result, put it into a success, and then send that down the pipe. Now, in the case of it's a failure, notice how I was saying in the previous slide where we don't have to deal with exceptions anymore. Well, that's sort of not totally true. We're always going to have exceptions in Ruby just because it's a dynamic language and there's things that can go wrong, right? We don't have a compiler that can help us prevent us from having exceptions. But in this case, I know that there could potentially be a timeout error. So I'm going to capture that and I'm going to put that into a failure monad. So now I have my success and I have my failure. So before I go on, any questions about this? Is this tracking okay? We'll come back to this in a little bit, but just checking. Okay, everybody.
So fmap right there is the thing that creates the thing that gets passed further down the pipeline?
Well, what fmap does is it's a function map. So basically it has a monad coming in. And if the monad is a success, function map will open up and let you unwrap that monad, the URL that's inside of it. in that block and then process it, only on success. This block won't fire if it's not a success. If it's
FMAP will like return a failure or something like that, or FMAP just wouldn't get called, or?
So FMAP wouldn't get called if it's not a success. If it's a failure, it just doesn't fire.
Okay.
If it's a success, what it does though is it'll calculate this, and then that result that is calculated in here, basically the HTTP response that's coming back, it's going to wrap that into a new success and then send that down the pipe.
Okay.
Yeah. Yeah. Does that make sense?
Yeah, FMAP is the transactable. Is FMAP out of transactional, or is that a?
It's part of the dry monads API. Okay. So once you have a monad, you have some additional methods that you can query. Yeah. Yep. So the last thing that we need to look at is just that report method that we had in the previous. It was the last method in our pipeline. So again, when we did method report, we grabbed that private method, we turned it into a method so we can call it. And again, we're using a monad here, so only if it's successful we fire this. But that HTTP response that came from that previous slide that Dan was asking about, where we get that HTTP response back, that's going to get, if that's a success, that gets wrapped as a monad. It comes in here, and then when we unwrap it, we get this. We can ask the status of the HTTP response. Are you a 200? And we're just doing a ternary here. So if it's a 200, the site's up. Yay, we pinged it. It's good. If it's not, then we just spit out the status, whatever the HTTP status is that came back. So that's it. Now, what this looks like then, if we want to call this, now that we've built our implementation, at the very bottom of the script, all we need to do is call it to fire the implementation. So what we need to do is just bring in dry monads here. I'm just going to bring in the result because I'm going to use pattern matching. You can see down here below. And then I'm going to send in the xkcd URL, which as our input, and we're just going to ping it. So let's just see if the site's up. I'm going to take the pinger, I'm going to new it up. I'm going to call it with that URL. And then I'm going to pattern match because the pipeline that's being fired here, right, what spits out at the end is a monad. So that means that we can do pattern matching, which is awesome. So if it's a success, we unwrap the success in pattern matching. We get the message that's inside the monad, and then we spit out the message that came back from the server. If it's a failure, we unwrap the failure because it's in a failure monad. We get the error out of it, and then we spit out the error to the command line, all using pattern matching. Just this is not even special to monads. It's just Ruby at this point. So what does this look like then? If we go ahead and run this output, what are we going to get from this little program that we wrote? Well, if we pass in the xkcd URL, that's fine. It pings the server, site's up, success. Looks good. If we actually forget to drop the HTTPS and we just do an HTTP call, a non-secure call, the checking that we were doing, that pattern matching, I'll come back to that in just a moment, it's going to fail and say, we think the site's down. Here's the reason, right? And we can see that we didn't give it the HTTPS protocol. And in the case where we send in some gobbledygook, URL, that doesn't exist. What it's going to do is it's going to hit that timeout. So that timeout in the code that we had for the HTTP client at 1 second, it's going to try to ping it, sees that it can't, it raises that error. We wrap that error into a failure monad, and then we pattern match and spit it out here at the end. So we get this nice output. So you can see that there's a lot of cool things happening. The program never blew up. We had a success path, we had a failure path, and we were able to handle all those situations really gracefully. Now, we could have done some things where we recovered from it, but that's a little bit outside of the scope of here, but that's something else that we could do within that pipeline flow. Now, if we kind of rewind this and kind of go back to that pipe, now that you've seen how the code's constructed and how the output came out, let's take a closer look at what this pipe is doing. So if we look at the URL coming in, nothing too special there, but what pipe is doing is immediately wrapping that into a monad because it has to be monads all the way down through. Otherwise, we can't have our nice railway pattern. Then we're using T. T is doing that checking that you saw in the output, checking the URL to see if it works. T in Ruby, basically the DSL that I built into Transactionable is very much like T if you're a Linux/Unix user who's very used to piping your commands on the shell and then put T in to just basically have a side effect, but then the pipe still fires off. This is just a nice way to spit something out as a side effect. Then we do a check, and all it's doing is just checking to see if the regular expression for HTTPS works. If not, then that's a failure and the rest of the steps fail. That's how the XKCD without the S in the protocol and the call that we did in that slide, that's why that failed. Then there's our method get. So if the check is fine, it comes through, it's going to do the HTTP call to the server to see if the site's up. Then the as is just a little bit of nice syntactical sugar of the transactionable DSL. It's just saying, hey, the result that you got back, I just want you to convert yourself as the status. So basically just sends the message status to that object. So an HTTP response object, whether you've worked with HTTP gem or not, you can always ask your HTTP response for a status, right? And then you can ask status for the code and so forth. So that's all we're doing here is we're just converting it. And then finally, we're just saying, hey, once we get the status, wrap that into a success monad, send that to the report, it'll unwrap it and spit out, is the site up based on the code or not? And that's it. So that's kind of what's happening in a nutshell there. So if we look at this, what's really cool about this, when I was kind of grumbling before in the previous slides, where I was saying like in native Ruby, right, we're composing our methods and we have to read from right and then left to right or right to left. Now we have something really cool happening where we have a nice DSL from Transactionable where we're reading top to bottom, flows really well. There's no jumping around. Our input is the very first parameter always, and everything else is all our operations that we're going to do as we step through this flow. If this was not so many steps, it could be written from left to right as well. It could fit just horizontally as well. So some really nice elegance there. The other thing that's nice about this too is from an architectural perspective, right, there's our input coming in. All these others are just our operations. And then between the operations, it's just monads. And those monads are either success or failure. So it can kind of flow through this pipeline really easily. What's also interesting about this is that you could have something like a URL that comes in that's bad, and then all those steps, they walk through them, but since it's a failure, they just pass through. It doesn't throw an exception like in normal native Ruby code, it just passes all the way through. You could have a situation where it goes through the first two steps, it's fine, but the last, something happens on the get and then everything else failed. That's fine. Or you could have a situation where it does a get, and HTTP get, but by the time it gets to the as step, maybe we put some special sophisticated logic in there to basically recover from that somehow. So this gives us that way to kind of have multiple branching paths where we can take something that's a failure and turn it into something that's a success and still have a good output that maybe goes back to our customers. A good example of this would be like, you've probably written this many times when you're dealing with third-party APIs and it's a flaky, stupid service, and you're like, I gotta make an API call, I gotta get a response back, but the damn thing is either up or down half the time. What you could do is you could have it make the response, you get back a failure, and then you trail off 5 seconds, make another response, see if you can get the response back, maybe trail off wait another 10 seconds this time, and then hit it again, and then finally get a response. That's how you could heal and still get your your success. So at the end of the day, what this is really doing is it's using all the fundamentals that we talked about earlier, just basic function composition and just functions in general in Ruby, mixing in a little bit of dry monads just to give us a way to basically build that railway pipeline pattern. And then adding transactionable on top to give us a DSL that allows us to write really nice code that really takes only a few steps and is just very procedural. So that's kind of function composition in a nutshell. Thanks for letting me talk. Feel free to connect with me online. I write, speak, talk about all things Ruby all the time. Really love this. And then I work with a whole bunch of cool tech stack as well. So I guess any questions? Maybe the silent, maybe I stunned everybody, bored everyone.
So I guess as you're walking through the composition stuff, I kept saying, yeah, it's a cool way to do addition or multiplication that I could do simpler with just using, plus, minus, et cetera, right? Like, I understand that's because that's a simple example. Yeah. And obviously you could do that entire pipeline with if-else statements and maybe with classes. So where would you reach for this kind of thing that simplifies the writing, but maybe doesn't simplify the understanding, or is it trade-off? Like, when would you reach for what you just talked about, I guess?
Yeah, that's a really good question. And it actually comes up a lot, especially when I'm dealing with team members or working with clients that are not as familiar with this. It's a common question that always comes up. And there is a little bit of a trade-off. You're absolutely right. And the trade-off is that the syntax and the way of thinking is just a little different than what a lot of people are used to in Ruby. And that comes with not just functional composition in Ruby that you have for native support, but just the dry libraries in general. They cause you to think a little bit differently. And the reason is because the dry RB libraries really emphasize functional programming in Ruby. And I love it because, well, being an Elm guy as well and working with functional language as well, I love being able to bring the best of functional into Ruby. But at the end of the day, Ruby is my true passion. Like, I just love the language so much, and I love that I can take my objects and I can blend them with functional, and I can get the best of both worlds. But you're absolutely right, Dan. Like, it's a little bit of a shift, and but once you get used to it, you start to feel at home. It's really, once you start to write enough of it, it doesn't become something that's jarring to read. But you're right. If you look at if I go back, in fact, let's look at this slide again. Because there's a little bit of a DSL there coming in from Transactionable, that is something that, like, it's fairly kind of intuitive, but you might scratch your head. You're like, well, wait, how does as really kind of work? How does check actually work in this case, right? If you're not familiar with T tries to at least pull from Linux Unix. So hopefully if you're Linux Unix heads, you'll be like, oh yeah, okay, I see how this translates in Ruby. So there are problems there. This gem is still kind of young. I'm still trying to get the performance down so that it's really good for production purposes, but definitely open to input on better ways of actually writing this, making it more intuitive. I don't have a good answer for that specifically. I'm still trying to nestle with this so that this syntax for dealing with pipelines is a little bit more easier to pick up immediately, kind of grok and be like, yeah, okay, this is really cool. I actually want to keep working with this. So, but the trade-off, I guess, to kind of wrap up your question, Dan, is even though there's a little bit of a different way of kind of looking at things, kind of bending things a little bit. What is it? It's you that bends, not the spoon that bends type thing. But like, if you just kind of be a little malleable, it leads to really good code. Because when you write, a good example of this is you could look at my Gub gem. It's basically a GitHub client, but it's written using Transactionable and monads the entire way through as a API client to the GitHub API. You can see that it takes very little code to pull this off, and it's more reliable because of it. So it is different, but I actually, because I've been using this so much and so often, I really can't go back to just using, native exceptions or if-else statements or really complex case statements. It's really nice just to have a monad that's either a success or failure and then just let it flow through. So I know that was a little long-winded, but it hopefully answers your question. Yeah.
On one of the slides, you're including composable in one of the classes.
Yeah.
Is that, only ever used that module. Is that like a Ruby module?
Oh, yes. That's just a module that's part of the transactionable gem. So when you download and use it, I was just saying that just know that you could add that into your classes if you bring the transactional gem in. You don't have to, because transactionable, if you use the pipe syntax here, it kind of just does that all for you. So, yeah. But I was showing you that modules just so you know how little lines of code it takes to actually turn any of your Ruby objects into something that can be composable. That's kind of the key emphasis.
Right.
Yeah. Yeah.
Cool.
Great. Thank you. I think these are really valuable talks to have because you start thinking about things in a slightly different way, which is always, I think, valuable because you can question your assumptions. Like you're saying, you start using it and it makes more and more sense.
Yeah. Yeah. Yeah, it was actually something, I don't know, for some of you in Ruby, Boulder Ruby Slack, it was something I was asking this summer. I was poking around, and I think it was Sean that piped in. He's like, well, you should try inheriting from the proc class, but you don't want to inherit from primitives in Ruby. This is kind of a dark path to go down, just because primitives in Ruby are written in C, and you can get yourself into a whole lot of trouble if you go down that path from inheritance. So I tried it for a little bit, and it is kind of interesting to try that to build this pipeline flow, but I stayed with pure objects to pull this off. But yeah, I think these things are really important to think about. I've been trying to solve this problem of having transactionable objects that can use composition and use some of the things that you're kind of used to in Ruby and just tie them together in a nice bow. So that's what Transactionable is trying to do here. The corollary to this is there is actually a gem in the dry library ecosystem called dry transaction that works similar to this, but it doesn't use composition. So this is kind of a parallel pattern idea that I'm working on that I really like so far that doesn't have some of the baggage that comes with dry transactions. So, yeah.
Not sure if Chris was trying to say something or just misread. Oh, I think Chris does have his hand raised. Chris, go ahead.
Yeah, my computer was locked up. Sorry about that. Hey, so I was trying to ask, you just mentioned it, Brooke. I was curious because I saw the dry monad was included.
Yeah.
And that comes from dry RB, the dry RB paradigm. And so I was really kind of curious how different that was than dry transaction. So you kind of, because that's something I've noticed that they could be very, very different. They could be very similar in how they're chaining things together. But I noticed how that basic pipeline you created was similar to what transaction does. But I was hoping you could maybe highlight some of the differences there between those two, because that's something that's always confused me about the dry RB ecosystem.
Yeah, that's a good question. So let me bring this up really quick. So let's look at dry transaction and just answer Chris's question really quickly. So dry transaction is basically the same thing I was doing. You can kind of see it here in the syntax. You include dry transaction, so not too much different than what I was doing. But the way that it changes is the steps are at the class level. So it's class level macros. And then you have your methods that are private in between. I don't really like this syntax. When I first came across it, actually working with Paul, he's not here tonight, but he really likes this, and I don't, because there's a bunch of nuance to this, to the way these steps work and the way that you pass your data down. It can start to lead to some pretty gnarly situations that are hard to debug. And with transactionable, I'm trying to keep it so that you're just basically staying within your class. You're using normal methods. You just got the methods that were included from dry transaction, just the DSL that's coming in here. That's all you have to care about, and it's within the instance of your class. With dry transaction, you're actually working with step functions basically at the macro level. And then you actually have to include dry monads if you want to make a new monad in here. I don't force you to do that in transactionable. Now, this probably won't make a lot of sense if you haven't messed with dry transaction, so I guess I won't spend too much time on it, but that's kind of the rough translation between the two. They're both trying to do the same thing, except I'm focusing on functional composition. This doesn't use functional composition at all, but it is actually using the railway pattern of building a transactionable object that has multiple operations.
So you could do a similar thing if you include a dry monad like you're doing, but it's going to be a little more convoluted or some such. If you were passing monads down each step.
They're different paradigms. I mean, right? I mean, that's the kind of thoughts. I mean, they're similar, but there's also some differences. Like the steps, the macro steps, actually, this is a very simple example, but you can do a lot of, think of them like validators on a model. You can do a lot of stuff in the steps before you instantiate each of the items in the sequence. So in my past life, we were using them for complex workflows but dry monads was always, I always thought, I was interesting because go ahead. Sorry, didn't mean to interrupt you there, but that's dry monads. It seems to be a little bit simpler in some ways.
Yeah, It's you're absolutely right. You can actually bring in with dry transaction, you can actually have like a validate step. Oh, actually, it doesn't come native. Actually, you'd have to kind of build it yourself. But you could actually have a step that actually uses dry validations to validate your input. But again, the syntax and way that you do this at a macro level, at the class level, is really just the same thing I'm doing with transactionable. It's just at the instance level. So they're really, it's kind of like you're hinting at, Chris. You're kind of splitting hairs a little bit, because it's like you could work at that class level, macro level with dry transaction, or you could work at the instance level like I'm doing with transactionable. So both concepts are the same in that regard.
Thank you. Thank you.
Yeah.
So like looking at the documentation for the dry transaction, how would you like translate that to transactable, would you say?
Yeah, so if you had your steps where you're doing a validate and then a create, that's really not much difference than taking some input. This would be your input, and then instead of T, that would be validate. Instead of check, it would be, sorry, I forgot what it was. Oh, create, and that's it. So you would just, change this to validate, and then this would be like, create. And the validate and create here, you could either have like private methods that does the validation, or what I would probably recommend, especially for the validation, is I would use dry validations and then have that be injected within your constructor of this class that you're building the pipeline for, and then you could just call it here, right, and have it do the validation.
Okay.
If that makes sense.
Yeah, I think so.
Kind of, yeah. The validation that you're talking about looks like this. So you would have, in dry validations, you basically define what is required and what is optional. And then on this contract, you can call it. So the API is the same. Once you have a contract that can validate something, you can call it, pass in the data, and it's either going to come back as a success or a failure. Well, not initially, you have to enable the monads extension, but once you do that, you have that pipeline flow again. Dry validations, by the way, is awesome, and it's way better than validations in Rails. I would highly recommend, if anything, one of the tips to take away from tonight is throw out validations from your models and use dry validations. It's actually more performant and way faster and even better memory than validations in Rails.
You said you're talking about using, instead of active model validations, use the dry validations instead. Is that what you're doing?
Yeah, exactly. So you would just write your validations as separate classes, and then in your controller or your business objects, whatever, you would couple the model, the record that's coming in, and then you'd inject your model record, and then your validator, and then you just, as one of your steps, you just validate to see, hey, is the model valid or not? And it's not much different than what you're doing at your model levels at the Rails levels, but you've got a way more powerful syntax. So
there is one caveat to that. So like there's some pros and cons. I would say it's not as of magnitude faster. It is measurable, but it's not as of magnitude. But it doesn't follow the same paradigm that active model validations do. So if you're in a Rails application, specifically a large monorail, and you're using that consistency as a strength, they're not the same, and they don't keep the shape the same, and they don't respond to the same core methods that everything else in Rails does.
Yeah, that's fair. That's good.
So like when we brought in dry validation, we had a lot of problems because we were trying to smash these together. Yeah. And it ended up being a ton of work. And so what ended up happening was, at the end of the day, it was slower than active model validations because you're mashing them together and you're not getting that speed bump, because dry RB to some extent is designed to work entirely inside of dry RB, not always mashed within Rails, is what we found out the hard way. Like that was one, dry validations was one of them that really, really bit us, because the active model validations were just easier to work in that paradigm. So it's like that pro and con, I think.
Yeah, no, that's a fair statement. If you're trying to do a hybrid approach, that I would not recommend that at all. What I usually do when I'm working in Rails apps is I'll completely take out the validations that's part of active record, active model, and just do everything with dry validations. So I would not merge them in that case. I can understand that being painful, but if you keep them pure and you just stick with dry validations, it's amazing. It makes for really easy maintainable code.
More chat. Kids going to bed from Dakota. See you, Dakota.
Anything else?
Cool. That's good.